We're now going to talk about parametrized surfaces. Let's first briefly recall how parametrized curves work. So a parametrized curve consists of the following information. So we have an interval which parametrizes the curve. So this goes from A to B. We'll call the parameter t. And we have a function which we'll denote by r, which is mapping this interval to a curve. Let's say we're doing a curve in three-dimensional space. So we have a function mapping this interval to R3. And we get some curve. Maybe it looks like this. So it's going from a point capital A, which is r of little a, to a point capital B, which is r of little b. And also recall that we have the velocity vector r prime of t. So if I write r of t equals x of t, y of t, z of t, then the velocity vector is x prime of t, y prime of t, z prime of t. And this is tangent to the curve. So when the velocity vector is non-zero, this points in the direction of the tangent line to the curve. So at a point over here, say, r prime of t is going to point something like this. Okay, so we know this already, and we now want to generalize this to surfaces. So for a parametrized surface, well, what's the difference? So now a surface is two-dimensional, so it needs two parameters. And we're going to call these parameters u and v. So here's the UV plane. And we're going to have some domain in the UV plane, which is going to parameterize our surface. So the interval AB on the real line is getting replaced by the domain D in the UV plane. And then we're going to have some function, which I'll denote by r as before, which is going to map this domain to a surface in three-dimensional space. So maybe it looks like this. And we'll call it S. Okay? So a point UV on the domain gets mapped to the point r of UV on the surface. And you can, maybe a horizontal line that's supposed to go through UV on the domain is going to get mapped to some curve on the surface. We could draw another horizontal line. Maybe that goes over here. Another horizontal line. Maybe this one goes over here. We could draw some vertical lines like this. So maybe if this vertical line goes like this, and this vertical line goes like that. Okay, so this is a pretty straightforward generalization of what we do with the curve. It's just now we have two parameters instead of one. And now the parametrizing domain, instead of just being an interval, can be some more interesting domain in the UV plane. So let's look at an example or two in the next lecture segment.